Today we can begin the new chapter, D and F block elements. It is the 8th chapter. In D and F block elements, it has mainly two parts. The first one is D block element and the second one F block element. In D block elements, we have to discuss properties of D block elements and their varying trends. After that, some important compounds of D block elements. This is actually a small chapter, and from the first part, that is properties of D block elements, we'll get some questions, and sometimes you may ask to write 2 or 3 properties of elements. There are about 12 or 13 properties that is discussed in your textbook. So you should have a basic idea about all these properties, and we can see it one by one. And the first one, formation of colored ion. You know, transition elements form colored ions. For example, ferrous sulfate, which is pale green in color, but ferric chloride, that is yellowish in color. Similarly, you know, potassium permanganate solution, which is pink in color. Copper sulfate solution, blue in color. Similarly, in the case of cobalt nitrate, that is purple color. So the transition metal compounds have color. Metal compounds contain metal ions. So we can say these are forming colored ions. And what is the reason for the formation of color? Transition metal compounds are colored. Why? We have one answer, D-D transition. That is the answer. And what is meant by this D-D transition? Study it in detail in the next chapter. But D-D transition, we know there are 5 d orbitals. There are 5 d orbitals in transition elements. Now, out of these 5 d orbitals, the degenerate orbitals means all the orbitals of same energy. And these 5 d orbitals, at the time of formation of compounds, the degeneracy will lose. That means it will split into 2 different energy levels. In some cases, 3 orbitals of lower energy and 2 orbitals of higher energy. In some other cases, 2 orbitals of lower energy and 3 orbitals of higher energy. In such cases, promotion of electron from lower d orbital to higher d orbitals are possible. This transition is known as D-D transition. And this energy gap, or the energy required for this transition, is in the visible region. Therefore, transition metal compounds are colored. So what is the reason for the color of transition metal compounds? Simply you can write D-D transition. When an electron from lower energy d orbital is excited to a high energy d orbital, the energy of excitation corresponds to the frequency of light absorbed. D-D transition. This frequency generally lies in the visible region. The color observed corresponds to the complementary color of the light absorbed. I think it is clear to you. And now the property, formation of interstitial compounds. This is a special property of transition metals. Interstitial space. What is interstitial space? In the first chapter, solid state, we discussed it. The voids, that is the interstitial space. Voids, that means the free spaces between the particles of a crystal. That is void. So in this void, small atoms like hydrogen, carbon, or nitrogen can exist. They will be trapped in these voids. And compounds formed by the presence of hydrogen, carbon, or nitrogen in the interstitial spaces of transition elements are known as interstitial compounds. And one of the important feature of this interstitial compound, they are non-stoichiometric. What is meant by non-stoichiometric? H2O, that is stoichiometric compound. For 2 hydrogen, 1 oxygen. Stoichiometry is there. But interstitial compounds are non-stoichiometric. You will understand it from the examples. TIC, Mn4N, Fe3H, VH0.56. Not simply VH 0.56. You cannot see any stoichiometry there. TIH 1.7. These are some of the examples. And what are the characteristics of these interstitial compounds? They have high melting point, higher than those of pure metals, comparatively higher melting point than pure metals. And the second one, they are very hard. Some borides approach diamond in hardness, high increase in hardness. Third, they retain metallic conductivity. Even after the formation of interstitial compound, they have the property of conductance. And they are chemically inert. So interstitial compounds have some advantages over metals. Their conductivity increases and their inertness increases. Therefore, it will not undergo decay quickly. Another important property is alloy formation. You know, alloys are homogeneous solutions of 2 metals, and some non-metals also may be with it. A homogeneous solid solution in which atoms of one metal are distributed randomly among the atoms of the other. You can simply say homogeneous solution of 2 or more metals. Such alloys are formed by atoms with metallic radii that are within about 15% of each other. So that is the condition for the alloy formation. Metallic radii, the difference between the metallic radii should not be more than 15%. That is a condition. Within about 15% each other. And because of the similar radii and other characteristics of transition metals, alloys are readily formed by these metals. In the case of, we discussed in the case of transition metals, there is horizontal and vertical similarities. So the change in the radii is smaller as compared to elements of other block. So their radii are almost in this region. That means there is no considerable difference. Therefore, the metals can form alloys very easily. As the beginning, we can discuss these 3 properties today. Okay, we can discuss more properties in the next class.